Greeting to all committee and advisor. Our group is going to present about the effect of microbially induced calcium carbonate precipitation (MICP) on strength of mock-up of ancient Masonry. And the ancient site is a long-established learning center for arts, history, and archaeology. As a consequence, there is a problem of deterioration both from the human and from the nature. Currently, the main cause of destruction is from the nature, such as acid rain destruction, the current climate change, and the roots penetration. As a consequence, the organizer expects to use of the civil engineering knowledge in the prevention of the ancient sites. However, since the ancient site is historical significant, it is under authority and the supervisor of the Fine Arts Department. For act on the structure or the conduct any activity that has the impact on it, the producing the vibration or the employing the chemical method that have an impact on the region surrounding the ancient sites. As a result, there are the numerous constraints in terms of the maintenance.
But nowadays, there is the alternative technology to help improving soil quality, including the porous structures. Microbially induces calcium carbonate precipitations, or MICP, is a biotechnology using to increase the soil strength by the bacteria that can produce the calcium carbonate from enzymatic degradations of the urea that resulting the calcium carbonate to fulfill the void between the soil particle for compactions. The process of calcium carbonate productions starts by using the bacteria which can emit the urease enzyme to decompose the urea that is shown in the figure below. When the urea is combined with the moisture contents of the soils, the reactions will be producing the carbonate ion and ammonium ion. When the ammonium is released into the environment, resulting the higher pH level to the surrounding, the ammonium will induce the calcium ion that existing in the nature to react with the carbonate ion, which is also the product of the bacteria. And finally, they will combine and precipitate as the calcium carbonate as the equations below. Apart from applying MICP technology to improve the soil quality, MICP has recently adopted to some kinds of structures of building, such as the roof type or the ancient wall treatment. Therefore, our projects expect the possibility that the use of MICP techniques can be applied to treat the ancient masonry that have the porous on the surface due to the damage of UV light, acid, and humidity from the surroundings by using the calcium carbonate to fulfill the pore and expect that the masonry strength will be increased. In addition, MICP technology is also an alternative technique that is the most suitable method for restoring the ancient monument compared to the mechanical techniques that can cause the vibrations or the chemical process that may leave the contaminations on those historic sites. The project of this research is to increase the strength of the ancient masonry. In this project, the masonry will be taken to deteriorate to imitate the ancient bricks that have been deteriorated by the sunlight or moisture over a long time by using a QUV accelerated weathering tester as a catalyst for the deteriorations.
Next part is step of methodology. Begin with research and collecting data. Aim to observe MICP development on the mock-up ancient masonry of improving historic structures. Then will be bacteria culture for MICP, which is using bacteria name Sporosacina pasteuris. According to literature reviews, this bacteria has the ability to induce calcium carbonate sediment to combine sand particles together and can survive in an environment containing calcium chloride because it will not break down during the calcium carbonate formation process. Next step is preparing tools and samples by using substituting Masonry brick that has been certified by the Fine Arts Department with dimension of 5 x 15 x 30 centimeters. After that, the sample will be taken to physical property test by non-destructive test. In this research, we use ultrasonic pulse velocity to be non-destructive test. The reason why non-destructive testing must be included in this research because the samples are limited from lead to deterioration by QUV machine. So non-destructive testing is required to help in the analysis as well. Then the sample will be led to deterioration by QUV accelerated weathering tester, which can simulate the damage caused by sunlight, rain, and dew that occurs outdoors over months or years in a matter of days or weeks. After lead to deterioration, the sample will be taken to physical property test again. By this time, we'll be do both destructive and non-destructive tests. Then the sample will be treated with MICP method that bring the sample which already lead to deterioration by QUV accelerated weathering tester to treat it with MICP by spray the solution of MICP on the surface of Masonry mockup with the working pressure is between 0.69 to 1.38 bar, which is controlled by pneumatic gun regulator, and using fantail nozzle to spray solution on the sample surface so evenly. And then the sample will be taken to physical property test with both destructive and non-destructive tests again. After all processes, will be process of result analysis and conclusion. Our expected outcome is the mock-up of ancient masonries that were tested with MICP method can improve the strength and can be further developed for use in real historical sites.
This is our project schedule. For the schedule, we have done step of introduction, literature review, and the research methodology. Now, we are at the step of proposal project examination, and next we'll be preparing tool and sample in January 2022. The remaining step will be related to this project schedule. This is the completion of our project proposal. Thank you for your attention.